Hello. So in this video, I'm going to explain this problem, Jump Game 3. And so the thing is like most of the online resources which are explaining this problem are using recursion, but using recursion isn't a good idea in an interview or in a practical situation. It's good for understanding the problem, but one should ultimately know how to implement the algorithm in a iterative manner. So let's go through the code. If you want to understand how this the logic behind this problem, you can refer to some other video. So in this video, I'll be only explaining the iterative version of this code. So what is happening is that this problem is simply a if you have gone through the solution, if you know the algorithm, what you will see is that this is basically a graph algorithm. All right. So what I'm doing here in the code is that whatever the length of uh, the array is, right, we can assume that all those indices represent a node in a graph, and then I'm declaring a visited array, setting it initially as false, and then this is just a standard BFS search where I initiate the queue. I take a DQ and I insert the start index into the queue, and then until the queue is empty or I have found the node which is equal to 0, I'm going to keep looking for the left and right node and insert it into the queue. Okay. So in this line number 10, what I'm doing is that I'm checking what is the whether the queue is empty or not. If it is not, I'm taking out uh, the node that I had inserted. So as we all know that the DQ works in a first in first out fashion. Okay. So whatever the node that I have gotten, I'll check that whether the value of that node, and the values are stored in the array, ARR array. Okay. So I'll check that whether that value is 0 or not, and if it is 0, then we are done. Okay, then we return from here only. But if it is not 0, I'll mark it as visited, so that if I come to this node next time, if I see this node next time, I don't like recurse or like visit and start visit this node again. Okay. So if you know that the why do we do that is that do this is because if we visit this node, then it will become a cycle. Okay. So if there are, let's say, if there are, let's say, these two nodes, and A is pointing to B, and then B is pointing again to A, so this will create a cycle. Okay, and that we don't want. So once we visited node A, we will mark it as visited. So even if, let's say, we have a pointer which is pointing to A, when we see that A is already visited, we won't go to the back to that node A. And then once I have that the index of the current node, what I do is that I take the left and the right. How can we calculate the left? We know that, right, from the current index, if we uh, subtract the subtract the length which is given in the ARR array, we'll get the left index or the left node, and similarly we can get the right node. And then what we do is that we check whether this left is inbound, so that it is not falling on, like, it is not going below the 0 and above n above n minus 1. And if it is not visited, then I simply append it into the queue. Okay, and this happens again and again. If somehow this condition will not be executed, so that there isn't any node which is having a value 0, it will return false. And if I submit this code, you will see that this passed. Okay, with 91% time and 76% memory. Thank you.